Hi, and welcome to section 5.8, where we're going to talk about what are called conformationally mobile systems of molecules and how that relates to chirality. So, if you were to have, and conformationally mobile means that the molecules, as they are constantly flipping and twisting and moving around in solution. And so, it's up to us as chemists to think about if a moving, flipping molecule is achiral or chiral. So if we were to draw a Newman projection of some molecule, maybe this one in its gauche form, if we were to do a twist and this molecule were to twist all the way around here in a way that is the least energetically unfavorable to give us this, there we are. Are these the same molecule? Well, it turns out they are enantiomers because of the mirror plane you can draw here, right? They're the same, they're enantiomers. And they are also non-superimposable, right? So it seems like by our previous definitions, these two molecules that we just drew, or these two representations, should be enantiomers, right? Are they enantiomers? And the answer is no. They're not enantiomers because the molecule on the left is constantly rotating and can achieve the molecule on the right really, really quickly. And so, because of that, you can't actually measure the difference between the two. And so, the molecule here is said to be achiral. Something to note, however, is that if there were not enough energy for this molecule to rotate around, and you could maybe have this molecule without twisting, the one on the left, then that would be a chiral molecule if you could do that. But there's not a practical circumstance on Earth where that can happen. So, because of that, they are this. I don't think there's a practical circumstance on Earth. If you could reach absolute zero somewhere in a laboratory on Earth somehow, then that would work. But unless you can get to absolute zero here and stop the molecule from turning around, then these are not chiral. So anything that can twist or flip to give you different, or to give you a different structure that is not superimposable and non-mirror image is not chiral. So one last example is in a chair conformation. There we are, there's one chair. So if we have, let's say, this molecule, no, not that one, because it has a plane of symmetry. Let's do this molecule. Yes. Okay. If we do a ring flip, and now instead, we have this version of the molecule. They're non-mirror images, or they are non-superimposable non-mirror images, right? Very clearly, they're non-mirror images, and they're not superimposable. So they should be um, enantiomers or diastereomers. They should be diastereomers, really, right? Well, they're not, because again, we just did a ring flip to make these two differences, and cyclohexanes can ring flip relatively easily, and because of that, um, these two molecules are not chiral. So again, the takeaway from section 5.8 is that if you can flip or rotate a molecule and get some other structure, then that molecule and the other structure are identical and they are not chiral, and they are not enantiomers, nor are they diastereomers. So this has been section 5.8.